Today, we're going to do something a little different. We're going to go back, way, way back, to the very beginning of artificial intelligence to meet the one simple, elegant idea that kicked off this whole revolution. I mean, AI is just everywhere now, isn't it? You've got it writing essays, making these insane images. It's literally changing the world. But have you ever just stopped and wondered, where did all this stuff actually come from? Like, what's the origin story of something as wild as ChatGPT? Well, the answer is probably not what you'd expect. It didn't kick off with some giant supercomputer in a secret lab or a huge tech company. Nope. It all started with just one single, powerful idea. All right, let's get into it. It's time to meet the great-great-grandparent of every single AI model we use today. So this is it, the Perceptron. Now, get this. It was invented all the way back in 1957 by a psychologist, a guy named Frank Rosenblatt. And this was a huge deal. See, it wasn't just some rigid program. It was the very first mathematical model of a brain cell, a neuron, that could actually learn. It could look at examples, see where it went wrong, and then adjust itself to get smarter. I mean, that was absolutely revolutionary for the time. So how does this thing even think? Well, let's forget all the complicated math for a second. It's actually pretty simple. First, it takes in some information. We call those inputs. Then it kind of decides how important each piece of that info is. It gives them a weight. After that, it just adds all that weighted information together. And finally, based on that total, it makes a simple decision. Yes or no. That's really it. Simple, right? And that simple process? It turned out to be perfect for what's called binary classification. You know, any problem where there are only two possible answers. Think about it. Is this email spam or not spam? Is that tumor malignant or is it benign? It could even learn the basic logic gates like and or, which are the fundamental building blocks of all computers. But, and this is a big but, all of this early promise, this excitement, it was about to run headfirst into a brick wall, a huge one. There was this one simple little puzzle. It seemed so trivial that the Perceptron just couldn't solve. And this one failure, well, it nearly killed the entire field of AI. For real. Okay, so here's the heart of the problem. A Perceptron's whole thinking process was basically about drawing a single straight line, a line to separate all the yes answers from all the no answers. And if your problem couldn't be solved with one clean, straight cut like that, well, then it was game over. The Perceptron was stumped. And this right here, this is the puzzle that broke it. It's called the XOR problem, which stands for exclusive OR. Just look at the table. The idea is simple. The output should be 1 if either the first input or the second input is 1. But, and this is the key part, not if both of them are. For us, that makes total sense, right? But for a Perceptron, yeah, no way. It was completely impossible. Try it yourself in your head. There is just no way to draw a single straight line that puts the right answers on one side and the wrong ones on the other. In tech speak, the problem wasn't linearly separable. And that was its kryptonite. And the fallout from this was massive. I mean, this wasn't just some tiny bug they could patch. It was a fundamental core flaw. A really famous book in 1969 by Minsky and Papert proved it mathematically. And the whole field just collapsed. Funding completely dried up. All the excitement vanished. This was the start of the very first AI winter. It seriously looked like the whole dream of building intelligent machines was just over. But, you know, the story doesn't end there in the freezing cold of the AI winter. Nope. Decades later, a new breakthrough came along, and it didn't just solve this little puzzle. It basically resurrected the entire field and paved the way for every single piece of AI we have today. So, what was the big idea? Well, it was actually pretty elegant. If one straight line isn't enough to solve the problem, what if you use more than one? Researchers started stacking these perceptrons on top of each other, creating what we now call a multi-layer perceptron, or MLP. By adding these hidden layers of neurons in the middle, the network could suddenly learn to draw things that weren't just straight lines. It could combine them to make complex shapes, solving those nonlinear problems. Okay, but that created a whole new headache. How on earth do you train all those different layers at once? And this is where the real genius comes in. An algorithm that got popular around 1986 called backpropagation. It's like a coach for a sports team. After the play is over, the network looks at its final mistake, and the coach, backpropagation, sends a message backwards through the team telling each one exactly how they need to adjust so the whole team does better next time. It's literally the engine that drives all modern deep learning.
And so, with these two game-changing ideas working together, stacking the neurons into layers and then using backpropagation to train them, the infamous XOR problem was finally defeated. But, and this is so much more important, it wasn't just about XOR. This combo unlocked the ability to solve almost any pattern, no matter how complex you could imagine.
And this is where the story just explodes. Because that clever little fix for a logic puzzle from the 60s, it didn't just stay locked up in a research lab. Oh no, it kicked off a full-blown global revolution.
I mean, this timeline really says it all. Look at that long, quiet gap after 1969. That's the AI winter we talked about. Then, boom, 1986, backpropagation arrives. Things start to build, but kind of slowly, until 2012. That's when computing power finally got cheap and powerful enough to match the theory. And that was the spark that lit the fuse. From there, it's just been a rocket ship leading us straight to the transformer models that power everything today. And what's so wild is that when you peek under the hood of modern AI, you see the Perceptron's DNA everywhere. Those CNNs that are amazing at understanding images, you can think of them as just fancy MLPs designed for pixels. The RNNs that work with text and sequences, yep, same family tree. Even the almighty transformers, they're basically MLPs with a clever new trick called an attention layer added on. At their very core, every single one is a descendant of that original idea. And really, that is the key takeaway here. No matter how complicated, how magical AI seems right now, it is all, every bit of it, still built on that same core principle from the 1950s. You just take a bunch of simple, neuron-like units, stack them in layers, and let them learn together. So, let's wrap this up. What's the real legacy of this one little idea?
Everything. The entire AI revolution that we are living through right now, it all comes back to this. The power of one single idea. Think about it. The whole world-changing field of artificial intelligence, from self-driving cars to discovering new medicines, you can trace the family tree of all of it directly back to that one moment, to Frank Rosenblatt's simple attempt to mathematically describe a single learning neuron.
And that just leaves us with one last big question to think about. Back in the day, the XOR problem was like the great filter for AI. It was the big test it had to pass to survive and evolve. So standing here today on the edge of a totally new era, what do you think is the great filter for AI now?